3.2 notes. Today we're going to talk more specifically about parallel lines being cut by a transversal. So last time we just talked about any two lines being cut by a transversal, and that allowed us to identify four types of special angles that are created when the transversal is cut through the two lines. So now we're going to still talk about those four types of angles, but now our lines are parallel. So not only are we going to be able to name the angles, but since the lines are parallel, now we know the measures of the angles. So to get started, corresponding angles. So just to remind you, corresponding angles, remember these are angles that I would say are in the same spot, but a different intersection. So if we look at the diagram over here, I would say, okay, if I wanted some corresponding angles, I could say that angle 1 here and angle 2 are corresponding, because if I look at these intersections as four-way stops, 1 is in the upper left and 2 is in the upper left. So those would be referred to as corresponding angles. So now what happens is if you have two parallel lines, then if they're being cut by a transversal, you know that all the pairs of corresponding angles are congruent. So now you have to specifically know that the lines are parallel. As this diagram sits right here, the lines are not parallel. So symbols that indicate parallel is that you will have these arrows that are on top of the lines, or sometimes you see them drawn as a complete triangle that will be sitting right on top of the lines. So that is a symbol to let you know that those lines are parallel. If the lines are parallel, then corresponding angles are congruent. So the measure of angle 1 is going to be equal to the measure of angle 2. And that goes for all the pairs of corresponding angles. Like if I said if over here and here, all right, they would be corresponding, then they would also be congruent. So let's look at example 1, identify congruent angles. The measure of 3 of the numbered angles is 120. So basically what's that saying is out of this picture, 3 of the ones that still have numbers here are 120 degrees. We have to figure out which one of those are 120 degrees and then explain why. So first, if we look right here that this one is 120, well, we can't forget about our friends that we have, vertical angles and linear pairs, because they will always, always, always be our friends. We're never going to forget about them. So if this angle is 120, then that means that angle 4 is also 120. Because those are vertical angles, so the measure of angle 4 is 120. And why? Because it's a vertical angle with the one that's 120 degrees. Okay, so now if this one is 120, then let's use this whole thing that we just talked about, these corresponding angles. Well, if this one is 120, then we can also say, okay, well, see this 4? If I look at this as an intersection, the 4 is in the bottom right. If I go over here, 8 is in the bottom right. So not only is 4 120 degrees, but 8 is also 120 degrees. So the measure of angle 8 is 120 degrees. And why is because it is a corresponding angle with angle 4. And I'm just going to abbreviate corresponding with C-O-R-R and then angle. So that'll be corresponding angles. And so there should be another one that is 120. And there are a couple of different ways we can find it. So if this is, you see how here we have a pair of vertical angles and 120 and 4. Well, I could also come to this intersection and say, okay, 5 and 8 are vertical. So not only is 4 and 8 120, but angle 5 is also 120. and it is 120 degrees because it is a vertical angle with angle 8. So that's kind of how you use parallel lines. Now you cannot determine any of these angle measurements unless indeed they are parallel. So do you see how they put the little triangles right here on the lines? When lines are not parallel, all you can do is give them these special names that they have. You can only identify them. We can't use the names, this would be using the names, unless they're parallel. So now let's look at the alternate interior angles theorem. So just to briefly kind of remember what they are, alternate interior angles, they are inside the lines and they are on one side of the transversal, so they flip-flop from one side to the other. So if I were to just put in a pair of those, let's say this is angle 3 and this one is angle 4. So those would be a pair of alternate interior angles. I can identify 3 and 4 as alternate interior angles, and you can abbreviate that with AIA, you know, alternate interior angles. Now, though, we can identify, but if we know that the parallel lines are cut by a transversal, so there's the key. If they're parallel and they're cut by a transversal, then both pairs of the alternate interior angles are congruent. So basically we have another pair. So angle 3 is going to be congruent to angle 4. So the measure of angle 3 is equal to the measure of angle 4. And you also would have your other pair here if you did these two angles. They are also alternate interior angles. And they would also be congruent. So we forgot we need to make these lines parallel before we can determine anything about the measurements. We need to make sure we have parallel lines. So make sure the symbols are on there or you can't really determine any measurements. So let's look at this example 4, solve a real-world problem. When sunlight enters a drop of rain, different colors of light leave the drop at different angles. This process is what makes a rainbow. For violet light, the measure of angle 2 is 40 degrees. So in here is 40 degrees. What is the measure of angle 1? How do you know? Well, first of all, they have drawn some parallel lines in here. And what you need to kind of get used to is that if you're given anything that has parallel sides or parallel lines, you can always extend the lines out. Because remember, a line extends infinitely in both directions. So if we have some lines here, and these parallel lines and transversals are going to be embedded into all type of shapes that we will talk about in the future. Here is the transversal. Well, if you look at angle 2, it's 40 degrees. They're asking us about angle 1. So I say, what type of angles are those? They're on the inside. They're on opposite sides of the transversal. So these are actually alternate interior angles. Well, we just talked about right here that alternate interior angles are congruent. So if measure of angle 2 is 40, then the measure of angle 1 is also 40 degrees because of alternate interior angles are always congruent if the lines are parallel. All right, next are alternate exterior angles. So again, let's kind of refresh those. They are outside of the lines. They are on alternate sides of the transversal, so you have to go from one side to the other, so from the left to the right or top to bottom, depending on how the picture is arranged. So we can have, all right, this can be here. We could have angle 3 and angle 6. Those would be alternate exterior angles. We can abbreviate this alternate exterior angles, so we don't always have to write that out. Now, again, to reiterate, because it's very important, if the lines aren't parallel, all we can do is name them. Right now, my lines aren't parallel. However, what we're learning today is if the lines are indeed parallel, then both pairs of your alternate exterior angles are, what do you think? Congruent. So a lot of these are the same thing. So again, your alternate exterior angles are going to be congruent. So angle 3 is going to be congruent to angle 6, which is pretty much the same thing as the measure of angle 3 is going to equal the measure of angle 6. Remember, when we just talk about the pieces themselves, we say that they're congruent. When we talk about the actual measurements is when we change it to an equal sign. Now the last one is the consecutive interior angles. These sometimes are referred to as CIA. You can abbreviate that, consecutive interior angles. Again, they're on the interior of your lines, but this time consecutive means back to back. But in our case, consecutive means same side. So remember, sometimes in some books I told you that these are also called same side inside angles, because that's where they are at. They're on the same side and inside. So our angles here would be like angle 1 and angle 2. Those are consecutive interior angles. If you know that the lines are parallel, then both pairs of consecutive interior angles are supplementary. So be careful. This is the one that's different from all the other ones. So we have 4 types of special angles. We have the alternate interior, alternate exterior, and corresponding angles. So all 3 of those give you a measurement that is congruent. Consecutive interior angles, this last one, that's supplementary, and I know we all remember because we just tested over it that supplementary means that it's 2 angles that are going to add up to 180 degrees. So let's look at this example 2, and we're going to use the properties of parallel lines. We're going to find the value of x. So what we want to do is say, okay, here's the x. All right, well, this angle and angle 4, let's see. Let's try to remember their name and their relationship. They are on the same side inside. So right here, these 2 angles we just learned are going to be supplementary. So if I could find the measure of angle 4, I could actually set myself up an equation to find x. We can find the measure of angle 4 because of right here. If this is 115, then this one is 115. So the measure of angle 4 is 115 because, again, of the vertical angles. They're not going away. Never, 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 never. So now this is 115. So now, remember I told you we're going to do the same thing all year long? Here it is again. You know that these consecutive interior angles are supplementary. The definition of supplementary is 2 angles that add up to 180. That should be so familiar. Well, one angle is 115 degrees. The other angle right now is x plus 5. Combine like terms. My gosh, we've done this. X plus 120 equals 180. Solve for x. And by now, y'all are amazing at this. So x is 60. And that's how you use all of these special angles to solve for x and to find measurements of angles inside parallel lines.